All right, I'm going to do the 2018 FRQ number 1. If you look up here, this people entering a line for the escalator is this. So this is the people coming into the escalator, where R is going to be the number of people per second. So people per second means this is already a rate or a derivative. And again, time is in seconds. As people get on the escalator, they exit the escalator at a rate. So that rate, this same point right here, that 0.07 is the rate of people going out of people per second. And at time 0, there are 20 people in line. So there's already 20 people in line, and then these people are going to be getting more in line, and these people are getting off the escalator or out of line. And so this says how many people enter the line of the escalator from 0 to 300. Now, this enter is only enter. We don't care about the people coming out, so we only have the N. And when you do these problems on the AP test, you must show what you're typing in the calculator. So we're going to do the integral from 0 to 300 of R of t dt, and this is going to give us our answer we want. So I'm going to show you what I'm going to do on my calculator here. I gotta get my camera on here and move it over. So there's the problem. And then if you look, I've already typed in the two equations. I did the n one as y1, that's the in function, and the out function 0.7. I typed those into those two equations. And then I want to do math 9 because I'm doing an integral. I'm going from 0 to 300. And I type them out going in as y1, so I hit bars, y bars, function 1, and then dx, because I used x in my formulas, and I hit enter, and that's exactly 270 people. So this would equal 270 people. So during that 0 to 300 seconds, 270 people entered the line from t equals 0 to t equals 300 seconds. So that's number 1. The second one says during the time 0 to 300, there are people always people in line for the escalator. How many people are in line at 300? Okay, now this one's a little harder because now we got to take into the number of people that are coming in and the number of people that are going out. And we also need to remember there are 20 people at the beginning. So this is going to be 20, the number of people in the beginning that are there from 0 to 300. And then we are going to do R of t minus the 0.7 because we're going to take the people coming out of t. And that's going to be our answer. So I'm going to type that into my calculator and show you what to type in. And again, you must show that you're doing all this stuff. So I'm going to do 20 plus, and now I've already got that answer right there, right? That's already that first part. Now we're going to do it again. So I'm going to hit second enter, and I think it'll type that in there. So see, yeah. Okay, took away my plus 20. So I'm going to hit second insert 20 plus, and then there's that part. But I'm going to go in here and put minus the y2. So actually, probably even be faster just put the 0.7 in there and hit enter. And that's going to be 80. So let's go back. So this is going to be 80 people. So what that means is, and we would write another sentence, there are 80 people in line at the escalator at the time t equals 300. Okay, so you should write that whole thing out, but I don't have room on here to do this. Now for part C, it says, what is the first time t there are no people in line for the escalator? Now this says for t greater than 300. Okay, so it's greater than 300. So what I'm going to do is I'm going to do the integral from 0 to t, and I'm looking for this time when the people getting off the escalator is going to equal the 80 people that remained in line at time 300. So I want to find out when these two things are equal. So I'm kind of going to just do the integral of 0.7 is 0.7t, which equals 80. So the time when all these 80 people get out of line is going to be 80 over 0.7. So I'm going to do that on my calculator real quick. Oh, also, we need to remember that this is the time after 300. So it'd probably be a little faster if we went ahead and put starting at 300 plus, this is the time after 300 we're going to get. So we are still going to add 300 to this time. Actually, I'm not going to put that here. I'm going to do it at the end. All right, so I'm going to take on my calculator 80 divided by 0.7. I can get my camera to come back up here. It's not coming up for some, oh, it's come on the other side of the screen, so let me put it back over there. So 80 divided by 0.7 is going to give me that many seconds, and then I'm going to add that 300 back to it, and so that means at 400 some. So let me write this down. So t is approximately 114.286 seconds. That's after 300, so I have to say 300 plus 114.286 seconds. So this would be 414.286 seconds. So we would say at 414.286 seconds, there are no people in line, and you would write that sentence. And now we got part B, says for 0 to 300, at what time t is the number of people in line a minimum? Okay, so what we want to do here is we want to graph this thing, because we want to know at a certain time when these this thing is going to be at a minimum. So we want to use this rate to graph this, and this rate is going to give us the critical numbers. We're looking for the critical numbers we need. Now, it's not only this, but it's also these people coming out of line. So what I want to do is I want to find when the integral from 0 to some t of r of t minus 0.7 equals 0, as I left off my dt, will be my critical number. So I'm going to do that on my calculator right now. So I'm going to, oops, let me get my picture of my graph back up here. So I'm going to come down here and change this, and I'm going to make this vars, y vars, y1 minus, you know what, it'd be faster to do it on the front page probably. All right, we'll still do it this way anyway. I'm just going to put the 0.7 in there because that's just as quick as doing all that other var stuff. And I'm going to come over here and shut off the first two graphs. And I'm going to look at this graph from 0 to 300. So I'm going to change my window, which I've already got 0 to 300, and I got a Y window there, and I'm going to graph this. So it crosses once right there, so that's going to be one critical number. And then there's another critical number coming right there. And that looks like those are my two critical numbers. So I'm going to find those. So I'm going to hit second, calc 5. Nope, sorry, second, calc 2. I need the zeros here. So I'm going to go way back over here and find this 0. So I'm going to hit enter when it's below, go above, hit enter, and hit enter again. So one critical number is that, and I'm going to save that critical number in A. So I'm going to hit second, quit, and then I'm going to hit store X. So I hit X, and then I hit store. I'm going to hit that in alpha A because I'm going to need that number later. So that's one critical number, and then I'm going to do the other one. So I'm going to hit second, calc 2 again, and I'm going to come over here and find the other critical number. Probably is a little too far away from that, but it still should work all right. So there's my other critical number, and I'm going to store that one in B. oops, I can change that to X, store X and B. So there's the critical numbers. Okay, so I'm going to come back over here, and if you know to get max and mins, we're going to make a table. And the absolute max and absolute mins come from a table. So this is T, and then over here we're going to do R of T. Oops, I put F. Okay, it's actually going to be the integral of R of T here. So this is the integral because we want the people in line. Okay, so you remember you do the endpoints, so we know at 0 or 20, we knew at 300, we had 80 people. And then we got to use these two numbers that are still on my calculator, and you do not want to round these. Oops, looked down to get the number, and I wrote it up there too high. 0, 1, 3, 2, ... And the other one was 166.5747 ... And I'm going to plug these into my integral problem. So I'm going to go back to my graphing calculator here. Okay, so I'm going to hit Math 9. I'm going to go 0, 2, and if you remember, I stored that in A, so I'm going to hit alpha A, and then I'm going to come over here and put in my Y1, so I'm going to go vars, Y vars, 1, 1, minus, I'm going to put the 0.7 in there by hand because that's faster than doing the other one. And this is going to be my first one. Okay, I made a mistake somewhere, because you're not going to have negative people. Okay, I'm going to do this video in a minute, so hold on here. I got some people that want some questions asked. Okay, so anyway, I made a mistake when I typed this in because I forgot we started with 20 people in line. I didn't take that into account, so it's got to be 20 plus that thing. So I'm going to hit that again. All right, I got to come over here in front and put plus 20. So I'm going to hit second, enter, 20 plus, and then I hit enter. I forgot the 20 we started with. So at time 33.0, there's going to be approximately 3.803 people in line. And then we're going to go back to the calculator and I'm going to plug in that other number. Zoom in a little more here. All right, so then I'm going to hit second, enter, and it gives me the same thing because that's the fast way to go. And I go back to that A and I want alpha B, and I hit enter. So at that time, there's 158.070 people in line. Okay, and I should have put up here 20 plus this is the formula I want to use. That's what I typed into my calculator right here. Okay, for this thing. I don't really need this equals 0 part. And then I plug these numbers in. These are what I want, and I want the minimum. So out of all these numbers here, the two endpoints and the critical, oops, hit the wrong thing again. I want this one. This is the minimum right here. So I would write the minimum number of people in line, and you can actually use three different numbers here. You can say 3, you can say 3.803, or you can say is about 4, because we're not going to use a decimal point of a person. It's about 4 people at time equals 33.013 seconds. And that's the end of problem number 1.